Hello there, and welcome back to that quiet place where curiosity is allowed to wander slowly and where wonder is never in a hurry. Tonight, we're not going to look up at the stars. We're not going to chase galaxies or count the distances between worlds. Tonight, we're going to do something stranger and, in a way, far more intimate. We're going to look down, right now, wherever you are. Lying in the dark, the weight of the day finally loosening its grip. There is a whole world beneath you, not a metaphor, an actual world, layered and enormous and almost entirely unseen. It begins a few centimeters below your mattress, below the floor, below the foundation of the building you're in, below the soil and the bedrock, and it keeps going down and down and down, through rock that flows like honey over thousands of years, through an ocean of liquid metal, all the way to a solid heart that is as hot as the surface of the sun. And here is the strange part. You are closer to the center of the Earth, than you are to almost any city on the far side of the planet. The center is only about 6,000 kilometers straight down. And yet no one has ever been there. No one has come remotely close. We have sent machines past the edge of the solar system. We have photographed the shadow of a black hole. And we have never traveled more than a tiny scratch into the ground beneath our own feet. So tonight we go down, slowly, layer by layer. We'll pass through the soil and the stone, through caves and hidden rivers, through the boundary we've never crossed, into the deep furnace of the mantle, across an ocean of molten iron, and finally to the very center of everything, the still point at the middle of the world. Before we begin to sink into the earth, I'd love to know, as always, where in the world you're listening from tonight, and what the ground is like where you are. Is it stone? Is it sand? Is it the deep cold soil of somewhere northern? Or the warm red earth of somewhere closer to the equator? Wherever you are, the same astonishing structure waits beneath you. We're separated by oceans and time zones, and yet we're all standing, or resting, on the same vast hidden machine. If this kind of slow, downward wandering is your kind of wandering, it would mean a great deal if you tapped like or subscribed. It helps this quiet little signal find its way to other curious minds in the dark. No pressure, of course, just a small thank you, like a pebble dropped into a deep well, listening for the echo far below. So settle in, let yourself get heavy, let the bed hold you the way the earth holds everything else, and let your thoughts begin to sink, gently, downward, past the surface of things, into the layers of the world, where it is dark and warm and patient, and where the planet keeps its oldest secrets. We begin just below you, only a few centimeters down, with the thin, living skin of the world. Chapter 1. The ground you stand on. We almost never think about down. We think about forward and ahead and up. We build toward the sky. We measure the heights of mountains and the altitudes of plains. But down, the direction your whole body is being gently pulled, every second of your life, down is the direction we forget. It's the one place we cannot easily go, and so we treat it as though it isn't there. A floor, a foundation, the end of the visible. Solid ground, we say, as if solidity meant emptiness, as if there were nothing below but more of the same. But the first few meters beneath you are not nothing. They are, in fact, one of the most crowded and alive places on the entire planet. Start with soil. Not dirt, exactly. Soil is more than dirt. The top layer of the earth, the part that grows things, is a living material, thin as a coat of paint on a globe. In many places, it's only a handful of centimeters deep before it gives way to subsoil and stone. And in that thin skin lives an astonishing density life. A single spoonful of healthy soil can contain billions of microorganisms, more living things than there are people on Earth, held in the palm of your hand. Bacteria, fungi, microscopic animals, the thread-like networks of mycelium weaving between roots, all of it breathing and feeding and dying, and being reborn in slow, silent cycles. Just beneath the surface, roots reach down into the dark, drinking. Earthworms move through the soil, eating their way through the ground and turning it over, aerating it, in a process so slow and steady that over centuries it can bury entire ancient surfaces beneath fresh earth. Charles Darwin, near the end of his life, became quietly obsessed with earthworms. He calculated how much soil they moved, how they slowly swallowed the landscape and passed it through their bodies, how the very ground we walk on has, in many places, already passed through the gut of a worm. He saw in them a kind of patient, planetary engineering, small creatures given enough time, rewriting the surface of the world. Go a little deeper and the roots thin out. The life grows sparse. The soil gives way to a zone of broken rock and clay, the place where the surface world ends and the stone world begins. And here, already, only a few meters down, the everyday rules start to loosen. It is darker than any night. It is quieter than any silence you have heard. There is no wind, no weather, no day or night, just the steady, even hush of the ground, and a temperature that, a few meters down, stays almost exactly the same all year round. The frost of winter and the heat of summer fade out within the first meter or two. Below that, the earth keeps its own calm temperature, indifferent to the seasons turning overhead. This is why cellars stay cool, why caves feel timeless, why so many animals burrow. Just below the surface is one of the most stable environments on the planet, a place where nothing changes, sheltered from everything happening above, and we have lived in this thin top layer for our entire history without ever really descending into it. We dig graves and we dig foundations and we dig wells. We tunnel for trains and we mine for metal. But almost everything humans have ever built or buried sits within the first kilometer of the Earth. And the Earth is over 6,000 kilometers deep. If you imagine the whole planet shrunk to the size of an apple, then everything we have ever done, every mine, every tunnel, every borehole, every buried city, would fit within the thickness of the apple's skin. Thinner, even. A faint sheen on the surface, that's where we live, on the skin. And tonight, gently, we're going to peel it back, because just below the soil, just below the roots and the worms and the steady unchanging hush, there is a wall. Not a literal wall, but a transition. The place where loose earth becomes solid rock, where the soft surface gives way to the true outer shell of the planet. We're about to enter the crust. And the crust, despite its name, is anything but thin. Chapter 2. The skin of the world, we call it the crust, and the word makes it sound flimsy. A crust is the dry edge of something, the part you might leave behind. But the crust of the earth is, from our point of view, immense. And it is also the only part of the entire planet that human beings have ever touched. Beneath the continents, the crust is thick. In most places, it runs about 30 to 40 kilometers deep, and beneath the great mountain ranges, it can plunge to 70 kilometers or more. The rock pressing down with its own enormous weight, its roots reaching deep into the planet, the way an iceberg sits low beneath the waterline. Beneath the oceans, the crust is far thinner, sometimes only 5 or 6 kilometers between the seafloor and the layer below. Two kinds of crust, then: the thick, old, lightweight rock of the continents, some of it billions of years old, and the thin, young, dense rock of the ocean floor, constantly being made at the mid-ocean ridges and constantly being swallowed back down again. Now, here is something worth resting on for a moment. We have never dug all the way through even the thinnest part of the crust. Not once. The deepest hole human beings have ever made is a place you may never have heard of, in a cold and remote corner of northwestern Russia, near the border with Norway. It's called the Kola Superdeep Borehole. Beginning in 1970, Soviet scientists set out to drill as deep into the earth as they possibly could, not for oil, not for minerals, but purely to see how far down they could go, purely to find out what was there. They drilled for 19 years, and after 19 years of effort with the most advanced equipment of their age, they reached a depth of just over 12 kilometers. 12 kilometers. about 7.5 miles. It is to this day the deepest hole humanity has ever dug, and it did not even make it through the continental crust. It got perhaps a third of the way through. If the crust were the skin of that apple, the deepest hole we have ever drilled would not even fully pierce the skin. And down at the bottom of that hole, the world had become strange. The scientists had expected the rock to get steadily warmer, and it did, but it warmed faster than they predicted. At the bottom, the temperature had climbed past 180 degrees Celsius, far hotter than they had planned for. The rock at that depth, under that heat and that crushing pressure, began to behave less like solid stone and more like a thick plastic paste. The drill hole would slowly try to close itself, the rock flowing inward, sealing the wound. The heat damaged their equipment. Eventually, it became simply impossible to go further, and the project was abandoned, the hole capped, left behind. A rusting metal lid over the deepest point we have ever reached. A door welded shut on a journey we could not finish. But the Kola borehole left us with surprises that had nothing to do with how deep it went. Down in that ancient rock, billions of years old, the scientists found water. Water that should not have been there. Water that seemed to have been squeezed out of the minerals themselves under tremendous pressure. Water that had never seen the surface. And they found something even stranger. They found microscopic fossils. Tiny single-celled plankton preserved in rock kilometers below the ground. Traces of life from an ancient sea, carried down and locked away in the stone over unimaginable spans of time. And that brings us to one of the most quietly astonishing discoveries of the last several decades. Because we used to believe that life lived only on the surface, in the thin, lit layer of soil and sea and air. We thought of the deep rock as dead, too hot, too dark, too crushing, too starved of light and food for anything to survive. We were wrong. There is life down there, kilometers beneath your feet, in the pores and cracks of solid rock. There are living things, microbes, bacteria, and other tiny single-celled organisms that have made their homes in the deep crust, in places that never see the sun, that have never known light, that survive not on sunlight, or the sunlight grows, but on the faint chemical energy of the rocks and waters around them. Some of them split atoms of hydrogen from water. Some feed on minerals. They live in a darkness so complete and a stillness so total that their lives unfold at a pace we can barely imagine. Some of these deep microbes are thought to divide, to reproduce, perhaps only once in hundreds or even thousands of years. A single cell, alive, but so slowed down that a human lifetime is, to it, barely a moment. They are not quite dead, and not quite alive in the way we usually mean it. They simply persist, in the dark, in the deep, almost outside of time. Scientists have a name for this hidden realm. They call it the deep biosphere, and the more we look, the larger it seems to be. Some estimates suggest that the total mass of all this hidden underground life, all the microbes living kilometers down in the crust, in the rock beneath the continents and beneath the floor of the sea, may rival or even exceed the mass of all the life on the surface, all the forests, all the animals, all the people, all the fish in all the oceans. There may be just as much living matter hidden in the dark rock beneath us as there is in the entire sunlit world above. We sometimes wonder whether there is life on other planets, and all the while, we have barely noticed the vast, slow, patient biosphere living in the dark beneath our own feet. A second living world, layered beneath the first, breathing on a timescale of centuries. It's worth pausing, too, on the few places where human beings have actually gone down, not drilled a narrow hole, but physically descended, with our own bodies, into the deep rock. The deepest mines on Earth are astonishing, terrible places. In the gold mines of South Africa, miners ride elevators down for what feels like forever, descending nearly 4 kilometers below the surface to reach the richest seams. 4 kilometers down, The rock itself is hot to the touch. The temperature of the stone can reach 60 degrees Celsius, hot enough to cook, and the mines must be flooded with cold air pumped down from above just to make it survivable for the workers. The weight of the rock above is so immense that the stone can fail suddenly and violently, the mine groaning and cracking, sometimes bursting inward in what the miners call a rock burst. The planet, in a sense, complaining about the hole. These are the deepest places that human beings routinely go, and they are still only the thinnest scratch, 4 kilometers into a crust that runs 30-40 kilometers down into a planet that runs over 6,000. We have to descend into hell-like heat and crushing pressure just to reach a depth that, on the scale of the whole Earth, is barely a fingernail's width below the surface. And remember what waited at the bottom of the Kola borehole, that deepest of all holes, 12 kilometers down. The scientists there had expected to find, at a certain depth, a boundary between two kinds of rock that earthquake studies had hinted at. Instead, when they reached that depth, they found no such boundary. Only more granite, fractured and saturated with that mysterious deep water, water squeezed from the very minerals. The Earth had quietly contradicted their predictions, reminding them that even our best models of the shallow crust are guesses, refined by listening, never confirmed by touch. 12 kilometers down, the world was still surprising us. It always is. So the crust is not dead, and it is not thin, and it is not the end of anything. It is the doorway. A doorway thick with rock and warmth and ancient water and slow hidden life. And we have only barely cracked it open. But before we go deeper, before we leave behind the realm where humans can, in any sense, still go, there's something we've passed straight through without stopping. Hollows in the rock, spaces, rivers in the dark, the hidden architecture of caves and water that threads through the upper crust. Let's pause there for a while, in the open spaces underground, before the rock closes in for good. Chapter 3. The hollow places. Not all of the underground is solid. We tend to picture the ground as one continuous mass, rock all the way down, dense and unbroken. But the upper crust, especially where it's made of certain kinds of stone, is riddled with hollows, caves, chambers, passages, voids, an entire hidden architecture carved patiently over millions of years, mostly by something as gentle as water. It works like this. Rainwater, as it falls and as it seeps through soil, picks up a little carbon dioxide and becomes very slightly acidic, far too weak for you to ever notice, but acid enough, given time, to do extraordinary things. Where this faintly acidic water meets limestone, a soft stone made largely of the compressed shells and skeletons of ancient sea creatures, it slowly dissolves it. Drop by drop, trickle by trickle, year by year, the water eats away at the stone, widening cracks into passages, passages into tunnels, tunnels into vast underground halls. This is how the great caves of the world are born, not blasted, not dug, but dissolved, patiently unmade by water over spans of time that dwarf all of human history. The largest known cave passage on Earth, a place called Sun Dung in Vietnam, is so enormous that it has its own weather. Clouds form inside it. A river runs along its floor. In places, the ceiling collapsed long ago, letting in shafts of light, and entire jungles have grown inside the cave. Full-size trees reaching up toward the openings in the roof. A forest sealed inside a mountain. You could fit a city block inside its largest chamber. A skyscraper could stand within it, and it sat there in the dark, undiscovered and unmapped by the wider world until just a few decades ago. A space that large, that close to the surface, and we simply hadn't found it yet. That tells you something about how little of the underground we know. There are almost certainly enormous caverns beneath our feet right now that no living thing has ever entered. Sealed chambers with no opening to the surface. Hollow spaces full of still air or still water that have been sitting in perfect darkness since before there were human beings to wonder about them. And inside these caves, where there is no light and there has never been light, you find the slow art of the underground. Stalactites hanging from the ceiling like stone icicles, formed one mineral-laden drip at a time, growing perhaps a few centimeters in 1,000 years. Stalagmites rising to meet them from the floor, where they finally touch after tens of thousands of years of patient dripping. They form columns, pillars of stone, built drop by drop in the dark, with no one to see them. There are formations down there more delicate than glass, and chambers lined with crystals larger than human beings. In one famous cave in Mexico, beams of pure crystal grew to over 10 meters long, the size of fallen trees, in a chamber so hot and humid that a person can only survive inside it for minutes at a time. A cathedral of crystal, grown in total darkness, in air too hot to breathe for long. And there is water, so much water. Beneath the surface, the rock is not just full of caves, but full of moisture, held in the tiny spaces between grains of stone, in cracks and pores and hidden reservoirs. We call these underground stores aquifers, and they hold an astonishing quantity of fresh water, far more fresh water than all the rivers and lakes on the surface of the earth combined. When you drink from a well, you are drinking from this hidden sea. Some of that water fell as rain only recently, but some of the water held deep in the rock, is ancient. It fell as rain thousands, even tens of thousands of years ago, long before any city stood, and it has been moving through the stone ever so slowly ever since, traveling perhaps a few meters in a year, on a journey that began when the world was a very different place. When you draw it up, you are tasting rain that fell on a vanished landscape, under a sky watched by people long gone. There are rivers down there too, underground rivers, flowing through cave systems in total darkness, sometimes emerging suddenly from the base of a cliff, sometimes vanishing into the ground and never seen again. And in those black rivers and pools live creatures that have adapted to a world without light, pale, blind fish, ghostly white salamanders, insects and shrimp with no eyes and no color, because in absolute darkness, eyes and color are of no use to anyone. Some of these animals have lived in the dark for so many generations that their ancestors' eyes have simply faded away, evolved out of existence, useless and abandoned. They navigate by feel, by current, by the faint chemistry of the water. They have never seen, and they have never needed to. An entire branch of life, living out its whole story in the dark beneath us. It's a humbling thought, lying there in the dark yourself, that beneath you right now, there may be a slow black river you will never see, with pale blind things drifting in it, in a silence older than your species. It's worth dwelling, too, on what total darkness actually means down there, because it is something almost no one alive has ever truly experienced. In the deep parts of a cave, far from any opening, there is no light at all. Not dim light, not faint light, but the complete and perfect absence of it. Cave explorers describe switching off their lamps in such places and finding that their eyes never adjust, because there is nothing to adjust to. You can hold your hand against your face and see nothing. Hours could pass, days could pass, and it would make no difference. The darkness is the same in the deep cave, whether it is noon or midnight on the surface above, and the silence is just as complete, with no wind, no animals, no distant sound of anything. The loudest thing you can hear is the beating of your own heart and the rush of blood in your own ears. People who spend long enough in such places sometimes lose their sense of time entirely. In experiments where volunteers lived alone in deep caves for weeks or months, cut off from daylight and clocks, their bodies drifted free of the day, their sleeping and waking stretching out, sometimes into days that were 40 or 50 hours long, the human clock unmoored, drifting in the timeless dark. Perhaps this is why human beings have always imagined the deep places of the world as somewhere set apart. For as long as there have been people, there have been stories of the underworld. Nearly every culture that has ever lived placed something beneath the ground in its imagination, a realm of the dead, a land of shadows, a hidden world reached by descending into caves and the dark. The ancient Greeks imagined the underworld of Hades reached across a dark river. Other traditions spoke of caverns where spirits dwelt, of hollow mountains, of doorways in the deep, and it makes a kind of intuitive sense. The deep underground is the one direction we cannot follow the dead. The one place, genuinely sealed off from the living world, dark and silent and unknowable. It was natural to imagine that something waited there. Much later, when the age of science came, the dream took new forms, of vast hollow spaces inside the planet, of lost worlds beneath the crust, of a journey to the center of the earth. Those particular dreams turned out not to be true. The earth is not hollow, and there are no lost worlds in great caverns at its heart. And yet the deep instinct behind them was not so wrong. There is a hidden world beneath our feet. It is stranger than the old stories guessed, and far larger. But the feeling that something vast and unseen lies below us, that the ground is not merely the end of things but a door, that feeling was true all along. But these hollow places, the caves, the aquifers, the dark rivers, they all belong to the upper crust, the shallow world. As we sink deeper, the pressure rises, and the rock can no longer hold itself open. The hollows close. The caves give way to solid, unbroken stone, and then the stone itself begins to change. We are approaching a boundary now, a line drawn deep in the earth that we have known about for over a century, that we can detect with great precision, and that we have never once managed to reach. It's at the bottom of the crust and the top of the layer below. It has a name, and the story of how we found it is one of the most beautiful detective stories in all of science.
Chapter 4. The Door We Have Never Opened.
In the autumn of 1909, an earthquake shook the Balkans, in the region of Croatia. It was not, by the standards of earthquakes, an especially remarkable one, but a scientist named Andrija Mohorovičić happened to be studying the records from seismographs, the instruments that detect the trembling of the ground, and he noticed something that didn't make sense. When an earthquake happens, it sends waves of energy rippling out through the body of the planet in every direction, like sound through a great bell. And Mohorovičić, looking at the records of those waves, arriving at different stations, noticed that some of the waves were arriving too early, faster than they should have, as if they had found a shortcut. He thought about it carefully, and he realized what it meant. The early arriving waves had not traveled in a straight line along the surface. They had dived down into the earth, and at a certain depth they had hit a boundary, a place where the rock suddenly changed, where the waves suddenly sped up, and that boundary had bent them, refracted them, sent them racing along the faster, deeper rock before bending them back up to the surface. They arrived early because, for part of their journey, they had been traveling through a different and faster material than the rock of the crust. He had found, without ever seeing it, the bottom of the crust, the place where one kind of rock gives way to another, a boundary buried tens of kilometers down, invisible, untouchable, detected only because earthquake waves changed their speed when they crossed it. We named it after him, the Mohorovičić discontinuity, though almost everyone, mercifully, just calls it the Moho. The Moho is the floor of the world we know. Above it lies the crust, the rock of continents and ocean floors, the rock of mountains and mines, and the deepest holes we have ever drilled. Below it lies the mantle, made of denser, heavier rock, rock that behaves in ways the crust never does. The Moho is not always at the same depth. Beneath the oceans, it can be just 5 or 10 kilometers down, tantalizingly close, almost within reach. Beneath the continents and the mountains, it lies far deeper, 30, 40, 70 kilometers below the surface. And here is the quiet, almost unbelievable truth. We have never reached it, not once, not anywhere, in all of human history. with all of our machines, we have never drilled all the way through the crust and touched the mantle below. We have studied the mantle in 100 indirect ways. We have pieces of mantle rock that were carried up to the surface by volcanoes and by the slow grinding of tectonic plates. We can model it, map it, calculate its temperature and composition. But to drill down and actually pierce the moho, to pull up a fresh, untouched sample of the layer beneath the crust, that we have never done. People have tried. In the early 1960s, a group of American scientists launched an ambitious effort called Project Mohole. The idea was clever. Instead of drilling through the thick continental crust, drill through the thin oceanic crust, out at sea, where the moho is only a few kilometers below the seafloor. The problem was that the seafloor itself was under several kilometers of ocean. They would have to drill through deep water, and then through rock, from a floating on the surface, holding its position over a single point in the open sea. It was, for its time, an almost impossible engineering challenge. They managed to drill a short distance into the oceanic crust, a genuine achievement. But the full project ran over budget, ran into difficulties, and was eventually canceled before it could reach its goal. The moho remained untouched, and it remains untouched to this day. Right now, as you lie there, there is a boundary deep beneath you that we have known about for more than 100 years, that we can detect with exquisite precision, that marks the edge of everything we have ever physically reached. And we have never opened the door. The mantle, which makes up the overwhelming majority of the Earth's volume, the great bulk of the entire planet, has never been directly sampled in place by human hands. There is something almost dreamlike about that. We live our whole lives on top of a vast structure, most of which we will never touch. We know it's there. We can describe it in detail. We have simply never been able to go. So how then do we know anything at all about what lies below? If we cannot drill there, cannot dig there, cannot send any machine there, how do we know the mantle is hot, that the core is iron, that there is a solid sphere at the very center of the world? The answer is the same trick that revealed the moho in the first place. We listen. We listen to earthquakes. We let the planet ring like a bell, and we read the echoes. Let's spend a little while in that idea. The way we see into a world we can never enter, because it's one of the most elegant things our species has ever figured out. Chapter 5. Reading the echoes. Imagine you have a sealed box, and you are not allowed to open it. You cannot look inside. You cannot reach in. You can never know directly what it contains. But you are allowed to tap on the outside and listen to the sound it makes. If you tap it and it rings hollow, you learn something. If it makes a dull thud, you learn something else. If you tap one side and the sound comes through quickly, but tap another side and it comes through slow and muffled, you begin to build a picture of what's inside. Where it's dense, where it's empty, where the materials change. You could never see the contents. But by listening, carefully and cleverly enough, you could come to know them. This is essentially how we have mapped the interior of the Earth. The Earth is the sealed box, and earthquakes are the taps. When a large earthquake strikes anywhere on the planet, it releases an enormous burst of energy, and that energy travels outward through the body of the Earth as waves, seismic waves. They spread in all directions, plunging deep into the planet, passing through the crust and the mantle and the core, and emerging again, eventually, all over the surface of the world, where sensitive instruments record their arrival. By comparing when and where and how these waves arrive at hundreds of stations around the globe, scientists can reconstruct the path each wave took, and from the paths, they can work out what the waves traveled through. Now, there are two main kinds of seismic wave that travel through the body of the Earth, and the difference between them turns out to be the key that unlocked the whole interior. The first kind we call P waves, pressure waves. They move by squeezing and stretching the material they pass through, pushing it back and forth in the same direction the wave is traveling, like a sound wave moving through air. P waves are fast, and crucially, they can travel through anything: solid rock, liquid water, molten metal, gas. They don't mind. They push through it all. The second kind we call S waves, shear waves. They move differently. Instead of pushing material back and forth, they shake it from side to side, perpendicular to the direction of travel. The way a wave runs along a rope you flick at one end. And S waves have a peculiar and very important limitation. They can only travel through solids. They cannot pass through liquid at all. Liquids and gases have no rigidity, nothing to shear against, nothing to shake side to side. So an S wave that hits a body of liquid simply stops. It cannot get through. It dies at the edge. Hold on to that, because it is about to do something wonderful. In the early 20th century, as seismographs spread around the world, and scientists began comparing earthquake records globally, they noticed something strange about where the waves came out. When a big earthquake struck, P waves and S waves would emerge all over the planet as expected, except for certain regions on the far side of the Earth from the quake, where the waves seemed to vanish. There were zones, ring-shaped bands on the opposite face of the planet, where almost no direct waves arrived. They called these the shadow zones. The S waves, in particular, had a large shadow. Beyond a certain angle from the earthquake, the S waves simply did not appear on the far side of the planet at all. They went down into the Earth, and they never came out the other side. There was only one good explanation. Somewhere deep in the Earth, the S waves were hitting something they could not pass through, something that was not solid, a vast region deep in the planet made of liquid, because only a liquid could stop the shear waves dead, casting a shadow across the far side of the world. That liquid region is the outer core. We discovered it, its existence, its size, its boundaries, without ever seeing it, simply by noticing where earthquake waves failed to arrive. We learned that the heart of the Earth was partly molten by paying attention to a silence, to waves that didn't come. And then, in 1936, came an even more beautiful discovery, made by a Danish scientist named Inge Lehmann. Studying the faint waves that did manage to creep into the shadow zones, the weak echoes that should not have been there at all, she realized that some waves were arriving in places the liquid core model said should be empty. The only way to explain them was if, deep inside the great liquid outer core, there was something solid, a second core, a solid sphere sitting at the very center of the molten one, bending and reflecting the waves in just the right way to send faint echoes into the shadow. She had found the inner core, a solid ball at the center of the Earth, hidden inside a liquid shell, hidden inside the mantle, hidden inside the crust. And she found it once again by listening, by reading the faint and tangled echoes of earthquakes that had traveled all the way through the planet and out the other side. And there's one more thing the great earthquakes do, almost too beautiful to believe. When a truly enormous earthquake strikes, the largest kind, the ones that reshape coastlines, it does not just send waves racing once through the planet. It sets the entire Earth ringing. The whole planet, all 6,000 kilometers of it, begins to vibrate as a single object, swelling and shrinking by the tiniest amount, oscillating like an enormous bell that has just been struck. These vibrations are far too slow and too faint for any person to feel. A single ring can take nearly an hour to complete, the whole planet breathing in and out over the course of an hour. But our instruments can detect them, and after the greatest earthquakes, the Earth goes on humming this way for days, ringing softly to itself, the tone slowly fading. The planet has musical notes in a sense, deep, slow tones determined by its size and its structure, and a great enough earthquake plays them. And by studying the exact pitch of those notes, the way the planet rings, scientists learn still more about what's inside it. Because a bell's tone depends on what the bell is made of, we have, in effect, listened to the earth sing and read its structure in the song. There is something deeply moving about this, I think. We could not go down. We could not dig more than the faintest scratch into the surface. And yet, by being patient, by listening to the trembling of the ground and thinking very carefully about what we heard, we mapped the entire hidden structure of our world: the crust, the moho, the mantle, the liquid core, the solid heart within it. All of it discovered not by going there, but by listening to a planet ring. Every large earthquake, for all the harm it can do, also sends a wave of information sweeping through the earth, illuminating the interior the way a flash of lightning illuminates a dark landscape for an instant. And over a century of catching thus flashes, we have built up a picture of the inside of our world that is detailed and confident and, in its broad outlines, almost certainly correct, even though no human eye has ever seen any of it. So now, armed with the echoes, let us continue our descent. We've passed the soil and the cave and the deep biosphere. We've reached the bottom of the crust, the moho, the door we've never opened. Let us open it now, in our imagination, and step through into the largest layer of them all, the great slow sea of stone that makes up most of the planet, the mantle. Chapter 6. The sea of stone. If you could shrink yourself down and pass through the moho, through the door we have never opened, you would enter a realm so vast that it makes everything above it seem like a thin film. The mantle is the giant of the Earth's interior. It begins just below the crust and extends downward for nearly 2,900 kilometers, almost halfway to the center of the world. It makes up the great majority of the planet's volume, the overwhelming bulk of everything beneath your feet. The crust we live on is the merest skin by comparison. The mantle is the body, and the mantle is made of rock, solid rock. And this is the first thing your intuition has to wrestle with, lying there in the dark. Because the mantle is solid and yet it flows. How can something be solid and also flow? It seems like a contradiction, but it isn't. Not on the timescales the Earth works in. The rock of the mantle is under tremendous pressure and tremendous heat, and given enough time, not seconds or years, but thousands and millions of years, it can creep and ooze and circulate slowly, like an unimaginably thick fluid. Think of certain materials you may have handled. A putty that shatters if you strike it sharply, but slowly droops and flows if you simply leave it sitting. Strike the mantle quickly, with the sudden jolt of an earthquake wave, and it behaves like a solid, ringing and carrying the wave. But push on it gently and patiently over geological ages, and it flows like a slow, thick sea. And it does flow. The interior of the Earth is hot. Heat left over from the planet's violent birth, and heat constantly generated by the decay of radioactive elements scattered through the rock. That heat has to escape slowly outward toward the cold of space. And the way it escapes, in large part, is by convection. The hot rock deep in the mantle, warmed from below, becomes very slightly less dense, and it begins to rise. Agonizingly, slowly, perhaps a few centimeters a year, about the speed your fingernails grow. As it rises and nears the cooler upper regions, it gives up some of its heat, grows denser, and begins to sink again, up and down over millions of years in enormous slow churning cells. A sea of stone, turning over and over, the planet's way of carrying its inner heat to the surface. This slow churning is not some distant abstraction. It is the engine that drives the visible world. The continents themselves ride on top of this churning mantle, carried along on great plates of rock. The mantle's slow currents drag the plates across the face of the planet, pulling them apart in some places, where new crust wells up from below to fill the gap, and crushing them together in others, where mountains rise, and one plate dives beneath another, and sinks back down into the depths. Every mountain range, every ocean, every earthquake, every volcano, every continent that has ever drifted across the globe All of it is, in the end, the surface expression of that slow, hot sea turning over far below. The mantle breathes on a time scale of ages, and the whole face of the world is rearranged by its breathing. The mantle is not uniform either. As you descend through it, you pass through changes. The uppermost part, just below the crust, is relatively rigid, and together with the crust, it forms the hard plates that float on top, what we call the lithosphere, the hard shell of the planet. But a little deeper, perhaps 100 kilometers or so down, you reach a layer that is hotter and softer and weaker, where the rock is closer to its melting point and flows more easily. This soft layer is called the asthenosphere, and it acts almost like a lubricant, the slippery, yielding layer over which the hard plates above can slide. Without it, the continents could not drift at all. The world would be locked in place. Keep descending, and you pass through what scientists call the transition zone, a band a few hundred kilometers deep, where the pressure becomes so intense that the very crystals of the rock are squeezed into denser and denser arrangements. The minerals don't change what they're made of, but they change their structure, their packing, collapsing into tighter forms to survive the crushing weight above. And, hidden within some of these high-pressure minerals, scientists have found something they never expected. Water. Not liquid water, not oceans in caverns, but water locked into the crystal structure of the rock itself, bound up atom by atom within the minerals of the deep mantle, and there may be a great deal of it. Some scientists believe that, locked away in the rock of the transition zone, in mineral form, there could be as much water, or more, than in all the oceans on the surface of the earth. An ocean's worth of water, or several, hidden not as a sea, but as a faint dampness woven through the very stone, hundreds of kilometers down. We found the first solid evidence of it in a tiny flaw inside a diamond. A diamond formed deep in the mantle and carried up to the surface, carrying within it a microscopic pocket of a water-bearing mineral, a message in a bottle from a place we can never go. It told us that the deep earth is wetter than we ever imagined, that there are hidden oceans of a kind woven into the rock beneath us, and every so often the mantle sends us a message. We cannot go down into it, but now and then pieces of it come up to us. When certain rare and violent volcanic eruptions tear up from deep within the earth, they can rip out chunks of the mantle and carry them to the surface, embedded in the rising rock like raisins in bread. Geologists call these fragments xenoliths, foreign stones, and they are quite literally pieces of the deep earth that have come up to be held in a human hand. Green and dense and heavy, they are samples of a place we can never visit, delivered to the surface by accident, by the planet's own violence. And then there are diamonds. We tend to think of diamonds as jewelry, as ornaments, as something polished and set in rings. But a diamond is, first of all, a traveler from the deep. Diamonds form far down in the mantle, most of them well over 150 kilometers below the surface. In the heat and pressure of the deep rock, where carbon is squeezed into the hardest and most enduring arrangement it can take, they sit down there for hundreds of millions, even billions of years. And they only reach the surface when rare and explosive eruptions blast them upward fast enough that they survive the journey. Every natural diamond you have ever seen is older than the dinosaurs, born deep in the planet, carried up through the dark to glitter, eventually, in the light. They are the deepest things most people will ever touch. And some diamonds come from deeper still. There are rare stones, called superdeep diamonds, that formed not in the upper mantle, but hundreds of kilometers further down, near the transition zone or even below it. And as a diamond forms, it sometimes traps tiny flecks of the rock around it inside itself, sealed in, perfectly preserved, protected by the unbreakable crystal for the whole long journey up. Scientists who study these inclusions are, in effect, reading samples of the deep mantle that no drill could ever reach. It was exactly such a flaw, in exactly such a diamond, that gave us our first direct proof of water locked in the deep earth. A microscopic pocket of a water-bearing mineral that could only have formed hundreds of kilometers down, riding to the surface sealed inside a diamond like a message in a bottle, carrying news of hidden oceans up from a place we will never go. The most precious thing about some diamonds, it turns out, is not the gem at all. It is the speck of imperfection trapped inside, a tiny piece of the deep world, smuggled up into the light. The mantle, then, is a strange and magnificent place, solid yet flowing, still yet endlessly churning, dry yet holding oceans within its crystals, dark and hot and patient, carrying the planet's heat outward over the ages, carrying the continents on its back, reshaping the world so slowly that no single human life could ever see it move. And down at the very bottom of the mantle, nearly 3,000 kilometers below you, where the rock meets the liquid metal core, something even stranger waits. Two enormous structures, the size of continents, that have been sitting there, perhaps, for longer than the continents above have existed. We are only beginning to understand them, and they may be among the oldest and most mysterious features anywhere inside the earth. Let's drift down to the bottom of the Sea of Stone and meet them. Chapter 7. The Two Continents. That sank at the very bottom of the mantle, almost 3,000 kilometers down, the rock presses against the top of the molten core. This is a boundary almost as dramatic, in its way, as the surface of the earth. A place where solid stone meets liquid metal, where the temperature leaps upward by perhaps 1,000 degrees or more across a relatively thin transition, where the densest part of the rocky planet rests upon the heaviest. Scientists call this lowest layer of the mantle the D double prime layer, an oddly technical, unmusical name for one of the most mysterious places in the whole Earth. And resting on the floor of the mantle, sprawled across the top of the core, are two vast structures that we have only recently begun to map, and that we still do not fully understand. They show up when scientists pass enough earthquake waves through the deep earth and notice that, in two enormous regions, the waves slow down. The rock there is different, denser, or hotter, or made of something other than the surrounding mantle, slowing the waves that cross it. These two regions are colossal. Each one is the size of a continent. They are thousands of kilometers across and rise hundreds of kilometers up from the core mantle boundary like two great mountains, or two great piles, sitting on opposite sides of the earth, one beneath Africa and one beneath the Pacific Ocean. Scientists have taken to giving them names, half affectionate, half mythic. The one beneath Africa is sometimes called Tuzo, the one beneath the Pacific, Jason. Two hidden continents of strange rock, balanced on the iron sea at the base of the mantle. We don't know, with certainty, what they are. We don't know how old they are, or how they formed, or what they're made of. There are competing ideas, and they are wonderful to think about as you drift towards sleep. One idea is that these are graveyards, great heaps of ancient ocean floor. Over billions of years, the slabs of cold, dense crust that dive down into the earth at the edges of tectonic plates sink and keep sinking, all the way down through the mantle, until they finally settle at the very bottom and pile up against the core. In this view, the two great blobs are the accumulated wreckage of vanished oceans, seafloor that slipped beneath continents hundreds of millions of years ago, that has been falling slowly through the planet ever since, that has finally come to rest at the deepest place rock can go, the bottom of the world piled with the bones of dead seas. But there is another idea, stranger and more haunting. Some scientists believe these structures may be unimaginably old, older than the oceans, older than the continents, perhaps nearly as old as the Earth itself. They may be primordial, leftover material from the planet's violent formation that sank to the bottom and has remained there, almost undisturbed, for over 4 billion years, sealed away at the base of the mantle, untouched by the churning above. A buried memory of how the world was made. And there is one idea more remarkable still. Our moon, as far as we can tell, was born from a catastrophe, a collision, early in the solar system's history, between the young Earth and another planet roughly the size of Mars, a doomed world that scientists have named Theia. The impact was so violent that it nearly tore the Earth apart and flung a vast cloud of debris into orbit. Debris that gathered together to become the moon. And some scientists have proposed that pieces of Theia, fragments of that lost planet's body, denser than the rock around them, sank down through the molten young Earth and came to rest at the bottom of the mantle, where they remain to this day, as the two great blobs. If that idea is right, then, buried nearly 3,000 kilometers beneath your feet are the remains of another world, a whole planet that died before life began, its heart now resting inside our own. We may never know which of these stories is true. Perhaps it's a mixture, perhaps it's none of them, but it's worth simply holding the image, in the quiet of the night, that down at the very base of the rock, on opposite sides of the world, two structures the size of continents have been sitting in the dark and the heat for spans of time that make all of human history vanish to nothing. Older perhaps than the oceans, older perhaps than the Earth's familiar face, maybe the corpse of a lost planet, resting on a sea of liquid iron, untouched, unseen, almost beyond the reach of time. And from the edges of these structures, and from the hot boundary where rock meets metal, something rises. Now and then, in certain places, a plume of unusually hot mantle rock begins to lift away from the core mantle boundary and float upward, slowly, through the entire thickness of the mantle, like a column of warm wax in a lamp. These mantle plumes rise for tens of millions of years until they reach the underside of the crust, and there they burn through, creating hot spots, places where volcanoes erupt far from the edges of any plate. The Hawaiian Islands are the surface signature of such a plume, each island formed as the slow-moving plate drifted over a fixed fountain of heat rising from deep within the earth, a chain of volcation marking the path of the plate across a stationary flame far below. The hot ground beneath Yellowstone, with its geysers and its bubbling pools, may be another. These are the places where the deep earth reaches all the way to the surface, where the heat of the boundary, 3,000 kilometers down, comes up into the daylight and the open air, a thread connecting the bottom of the mantle to the world you can walk on. But we have lingered long enough at the floor of the mantle, below the rock, below the two ancient continents, below the D double prime layer. The world changes more completely than it has changed at any boundary we have crossed so far. The solid gives way at last. We leave the realm of stone entirely. Below us now is an ocean of liquid metal. Chapter 8. The ocean of iron, nearly 3,000 kilometers beneath you, the rock ends. Not gradually, but at a sharp and definite boundary. The core mantle boundary, the most dramatic transition anywhere inside the earth. Above it, solid rock. Below it, a vast sea of liquid metal, mostly iron, with some nickel mixed in, hot enough to glow if you could ever see it, though there is nothing down there to see it by. This is the outer core. It is about 2,200 kilometers thick, a shell of molten metal wrapped around the very center of the planet, larger by far than all the oceans of the surface, an ocean made not of water but of liquid iron, churning in the dark. It was this layer, you'll remember, that betrayed itself to us by swallowing the earthquake waves. The shear waves that can only travel through solids, that hit this liquid sea and stopped, casting their shadow across the far side of the planet. The outer core is the largest body of liquid inside the Earth, and one of the largest bodies of liquid anywhere in the solar system. And it is doing something extraordinary down there in the dark. It is generating the magnetic field that surrounds our entire planet. the invisible field that makes compass needles point north, the field that protects every living thing on the surface from the deadly radiation streaming endlessly from the sun. Here is how it works, as best we understand it. The outer core is molten metal, and molten metal conducts electricity. The core is also extremely hot at the bottom, near the inner core, and somewhat less hot at the top, near the mantle. So, just like the mantle above it, the outer core convects. The hot metal rises, gives up its heat to the mantle, and sinks again, churning in great slow currents. But this churning fluid is also caught up in the rotation of the planet. The whole Earth is spinning, once a day, and the spinning twists those rising and sinking currents into great spiraling, corkscrewing flows. And when you have an electrically conducting fluid moving in those kinds of organized spiraling currents, it does something almost magical. It generates a magnetic field. The motion of the metal creates electric currents. The electric currents create magnetism, and the magnetism in turn helps organize the motion. A self-sustaining loop, feeding on the heat escaping from the core, generating and regenerating the magnetic field as long as the core keeps churning. Scientists call this the geodynamo. It is, in effect, a planet-sized electrical generator running on the heat of the deep Earth, spinning out an invisible shield around the entire world. And what a shield it is! The sun does not only send us light and warmth, it also blasts out a constant stream of charged particles, the solar wind, racing across space at hundreds of kilometers a second. If that stream struck the Earth directly, unprotected, over the ages it could strip away the atmosphere, dry out the oceans, scour the surface with radiation. We have reason to believe this may be part of what happened to Mars, a smaller world whose interior cooled and whose magnetic dynamo faded long ago, leaving it exposed, its air stripped away, its water lost, a cold red desert under a naked sky. But the Earth's core still churns, the geodynamo still runs, and the magnetic field it generates reaches far out into space, deflecting the solar wind, turning it aside, holding it off. We almost never think about it. We cannot see it or feel it, but every moment of your life, that invisible field, generated by liquid iron churning 3,000 kilometers below you, is bending the deadly wind of the sun around the planet, keeping the air in the sky and the water in the seas. The aurora, the shimmering curtains of green and red light that dance over the far north and far south, are the visible edge of this protection. The solar wind, channeled by the magnetic field down toward the poles, lighting up the upper atmosphere as it strikes. When you see those lights, or pictures of them, you are watching the deep core's shield at work, glowing where it meets the storm, and the field is not constant. It wanders. The magnetic North Pole is not fixed. It drifts, year by year, as the currents in the core shift, sometimes wandering hundreds of kilometers over a human lifetime. And on far longer timescales, something stranger still happens. Every so often, every few 100,000 years on average, though with no regularity to it, the entire magnetic field of the planet weakens, falters, and then flips. North becomes south, and south becomes north. We can read the record of these reversals frozen into the rocks in the way ancient lava cooled and locked in the direction of the field. At the moment it solidified, layer after layer recording, flip after flip across millions of years. The last full reversal was around 780,000 years ago. There have been hundreds of them in the planet's history, and one will surely come again. Someday, the field guttering low like a candle in a draft, the compasses going mad, before the great dynamo finds its footing again, and the field returns, pointing the other way. It is humbling to think that something so fundamental to our world, the very direction of north, the shield that holds our air in place, is not a fixed feature of the planet, but the flickering, shifting product of a sea of metal, churning in the dark. A sea we have never seen and never will, 3,000 kilometers down. But the outer core, for all its size and power, is not the center. There is still one layer below it. The last one, the innermost, the strangest of all, because at the very heart of the liquid iron sea, there is a place where the iron is no longer liquid, where, against all intuition, despite a temperature as fierce as the surface of the sun, the metal is solid. We have arrived almost at the center of the earth. Let us go down into the inner core. Chapter 9, The Hidden Heart. At the center of the great molten ocean, there is a solid sphere of iron. It is about 1,200 kilometers in radius, roughly the size of the moon, give or take, though the moon is hollow of nothing, and this is solid metal through and through. It sits at the very center of the earth, surrounded on all sides by the liquid outer core, surrounded by the mantle, surrounded by the crust, surrounded by you, the inner core, the hidden heart of the world. And here is the riddle that makes it so wonderful. The inner core is hot, astonishingly hot. The temperature there is thought to be somewhere around 5,000 to 6,000 degrees Celsius, about as hot as the surface of the sun. At that temperature, iron should not be solid. Iron should be a vapor, a gas, far past melting and boiling. The outer core, cooler than the inner core, is liquid. So how can the center, the hottest place of all, be solid? The answer is pressure. The weight of the entire planet, the whole mantle, the whole outer core, all of it, presses down upon the center with a force almost impossible to imagine. The pressure at the very center of the Earth is something like 3.5 million times the pressure of the atmosphere at the surface. And under that unimaginable squeezing, the atoms of iron are forced so tightly together that they cannot break free into a liquid, no matter how hot they get. Heat wants to shake them loose. Pressure refuses to let them go, and pressure wins. The iron is locked into a solid by the sheer crushing weight of the world above it, a solid forged not by cold but by pressure. The hottest solid in the earth, kept solid by being buried beneath everything else. The inner core was not always there. In the deep past, the entire core was molten. There was no solid center at all, but the earth has been slowly cooling ever since it formed, leaking its heat away into space over billions of years. And as the center cooled, just slightly, the pressure at the very middle finally won out, and the iron there began to freeze. Not into ice, of course, but into solid metal. The inner core began as a tiny seed of solid iron at the exact center of the planet, and it has been growing ever since, freezing outward, crystal by crystal, as the earth cools. It grows perhaps a millimeter a year, adding over the whole surface of that buried sphere thousands of tons of new solid iron in a year, freezing out of the liquid sea around it. It is, in a sense, the slowest and deepest act of freezing anywhere in the world. A metal sphere slowly crystallizing at the center of the planet, growing imperceptibly larger across the ages. And this slow freezing matters far more than you might think, because when the iron freezes onto the inner core, it releases energy, heat, and also lighter elements that are squeezed out of the solidifying metal and rise up into the liquid outer core. And that rising, that release, helps stir the convection in the outer core. It helps power the great churning that runs the geodynamo, that generates the magnetic field, that shields the surface and holds our air in place. So the slow freezing of the hidden heart deep in the dark is part of what keeps the protective field alive. The growth of the inner core helps power the shield that protects all life. The deepest, stillest, most buried place in the world is quietly, across the ages, helping to keep the surface habitable. Everything is connected, all the way down. The inner core holds other mysteries too. The waves that pass through it suggest it is not perfectly uniform, that it travels at different speeds depending on which direction the waves move through it, as though it has a grain, like wood. Some scientists believe there may be an even deeper structure, an inner core, a distinct sphere at the very center of the center. with its own properties, hinting at some change in the way the iron crystallized in the very earliest days, a record of the planet's youth frozen at its core, a heart within the heart within the heart. And then there is the strangest possibility of all, the one that made headlines in recent years. The inner core, floating in the liquid outer core, is not perfectly locked to the rest of the planet. It can rotate slightly differently, spinning a touch faster or slower than the mantle and crust around it. For a time, scientists thought it might be spinning faster, racing slightly ahead of the rest of the world. More recent studies, reading the changes in earthquake waves over decades, suggest something even more delicate: that the inner core's rotation relative to the surface may speed up and slow down over cycles of decades, that it may have recently slowed and even begun, in a relative sense, to turn the other way. The picture is still being worked out, and scientists do not all agree. But sit with the image for a moment as you lie there in the dark. At the very center of the Earth, there is a solid sphere of iron the size of the moon, as hot as the surface of the sun, kept solid by the weight of the whole world, slowly freezing larger every year. And it is turning, gently, at its own pace, not quite in step with the ground beneath your feet. A separate, secret rotation, deep at the core of the world, that we can only detect by listening, once again, to the echoes of earthquakes that have passed all the way through. There is one more image worth carrying down into sleep with you, from the boundary where the liquid core meets the solid heart, because the inner core does not simply freeze in a smooth, even way at its surface. Some scientists believe that, in places, the iron may crystallize higher up in the liquid outer core and then drift slowly downward, that there may be, in effect, a kind of snow falling at the center of the Earth, not snow of water and ice, but snow of solid iron, tiny crystals forming in the molten metal and settling slowly down through the liquid onto the surface of the inner core below, building it up flake by flake, the way snow builds a drift, a storm of metal snow, falling forever in the dark, 3,000 kilometers down, in a place no light has ever reached and no eye will ever see. The strangest weather in the world, at the center of the world, falling without sound, and the inner core keeps its own quiet record of all of this. The way earthquake waves move through it differently in different directions. The hints of an innermost sphere at the very center. These are clues that the iron crystallized in different ways at different times, that the growth of the hidden heart has changed its character across the billions of years. Locked in the structure of that solid iron sphere is a frozen history of the planet's cooling, a record written in crystal that we are only just beginning to learn how to read. The deepest place in the world is also, in a sense, one of its oldest archives. We are almost at the end of our descent now. There is only one place left to go. Past the surface of the inner core, in through the solid iron, to the exact middle, the point around which everything else is arranged. The still center of the turning world. Let us go to the center. Chapter 10. The center. Imagine you could keep going, down through the crust, through the moho, through the sea of stone, past the two ancient at the bottom of the mantle, through the boundary into the liquid iron, across the whole churning ocean of molten metal, onto the surface of the solid inner core, and then in, through 1,200 kilometers of solid iron, until you arrive at the exact geometric center of the Earth. What is it like there? It is, first of all, the hottest place in the planet, around 5,000 or 6,000 degrees Celsius, the heat of a star's surface, held in the heart of a world. It is under the greatest pressure anywhere on Earth, some 3.5 million atmospheres. The entire weight of the planet pressing inward from every direction at once. It is solid iron, packed so tightly that the atoms can barely move, locked in place by that unimaginable crushing weight. And it is, in one strange and beautiful sense, weightless, because at the very center of the Earth, The pull of gravity points in no direction at all. Everywhere else on the planet, gravity pulls you down toward the center. But at the center itself, there is no down. The mass of the Earth surrounds you equally on all sides, pulling up just as hard as down, left as hard as right, in every direction, all the pulls canceling out perfectly. At the center, you would feel no weight. You would float in the heart of the world, suspended in solid iron, pulled equally toward everything and therefore toward nothing. The one place on the entire planet where the relentless downward tug that has governed your whole life, that is holding you against your bed right this moment, simply lets go. It is also, in a sense, the center of all directions. From that single point, every way is up. There is no other down to go. You could not fall any further because you would already be as deep can be. Every path from the center leads back toward the surface, back toward the light, back toward the air. It is the bottom of every well, the end of every descent, the deepest place that any down has ever pointed toward. There is an old thought experiment, a dream that has fascinated people for centuries. What would happen if you could drop a stone, or yourself, into a tunnel that went straight through the earth, from one side to the other, passing through the center? Ignore, for the dream's sake, the impossibility of it. The heat that would vaporize anything, the pressure, the liquid iron. Just imagine the fall. You would drop, and as you fell, you would go faster and faster, accelerating toward the center, the pull growing. No, the pull would actually weaken as you neared the middle, until at the very center it vanished. But by then you would be moving with tremendous speed, and so you would shoot straight through the center and out the other side, slowing now as gravity pulled you back, climbing, until you arrived at the far surface, having fallen all the way through the world, just barely reaching the opening on the other side before gravity drew you back, and you fell again, back through the center, and again, swinging back and forth through the heart of the planet forever, like a pendulum, like a held breath, like a slow and endless tide, a fall with no bottom, a drop that becomes simply a rhythm, down through the center and up the other side, and back again, forever, in the dark. It will never happen, of course. No such tunnel could ever exist. The center of the Earth is one of the few places in all the universe that is, in a deep sense, truly unreachable to us. Not because for it is closer than most cities, but because everything between here and there would destroy us long before we arrived. We can reach the moon. We can reach Mars. We have sent machines to the edge of the sun's influence and beyond. But the center of our own planet, 6,000 kilometers straight down, will almost certainly never feel the presence of a single living thing, not in all the time our species has left. It is the nearest unreachable place, the deep, dark, weightless, burning heart of the world, that we know is there, that we have mapped and measured and described in detail, and that no one will ever see. And yet it holds us, all of us, every continent, every ocean, every city, every forest, every person who has ever lived, all held in place, all the time, by the silent pull of that hidden heart. You have never thought about the center of the earth, most likely, on any ordinary day, and it has been holding you, faithfully, every single second of your life, holding the air against the sky, holding the seas in their basins, holding you, right now, gently against the place where you rest. We have reached the center. There is nowhere deeper to go. From here, every direction is the long way back up. But before we begin to rise, before we drift back toward the surface and towards sleep, let us stay a moment longer in the deep and think not about where these layers are, but about how old they are, and where all this heat came from, and how the burning heart beneath us is bound up with the living world above. Chapter 11. The long, slow cooling. Where did all the heat come from? The center of the earth is as hot as the surface of the sun. The whole interior is fiercely, enormously hot, and that heat has been there, in some form, for billions of years. Where did it come from? And why hasn't it all leaked away by now? Some of it is ancient, primordial heat, left over from the very birth of the planet. The Earth formed around 4.5 billion years ago, out of countless smaller bodies crashing together in the young solar system. Every collision, every impact, released energy as heat. As the growing planet gathered more and more material, it was bombarded relentlessly, and all that violence heated it up. And then, as the planet grew large enough, the heavy iron sank toward the center, and the lighter rock floated up. A great sorting out, the metal falling inward to form the core, and that falling too released a tremendous amount of energy, heating the young Earth still further. By the time it was done forming, the Earth was largely molten, a glowing sphere of melted rock and metal, hot from the violence of its own creation. Much of the heat still in the deep Earth today is the memory of that fiery birth. Warmth that has been slowly making its way outward, toward the surface and toward space, for 4.5 billion years, and has not yet finished its escape. But primordial heat is only part of the story. The Earth also generates new heat constantly from within. Scattered through the rock of the mantle and the crust are atoms of radioactive elements, uranium, thorium, potassium, and others. And these atoms decay slowly over enormous spans of time, breaking down and releasing little bursts of energy as they do. Each individual decay is tiny, but there are unimaginable numbers of these atoms spread through the body of the planet and decaying constantly, and together they generate an enormous, steady warmth from deep inside, a slow nuclear fire burning at a whisper all through the rock beneath you, keeping the interior hot, helping drive the churning of the mantle, helping keep the core molten and the dynamo alive. The Earth, in part, runs on a faint and ancient radioactivity woven through its own stone, and the Earth is cooling, slowly, inevitably. Over the billions of years of its life, the planet has been leaking its heat away into the cold of space, faster than even the radioactive fire can replace it. The interior is cooler now than it was in the deep past. The inner core is freezing larger as the center cools, and someday, far, far in the future, billions of years from now, the cooling will go further. The dynamo may weaken, the magnetic field may fade, the churning of the mantle may slow. The Earth, like Mars before it, may one day grow cold and still at its heart, its inner fire spent, its shield gone. It's worth sitting for a moment with how rare and precious this living interior may be. Look at our neighbors. Mars is a smaller world, and small worlds cool faster. They have less heat stored inside, and more surface to lose it through, relative to their size. Mars, it seems, cooled enough long ago that its churning core slowed, its dynamo faltered, and its magnetic field largely died. And once the shield was gone, the solar wind set to work, stripping away the air over hundreds of millions of years, until the planet that may once have had rivers and lakes and a thicker sky came the cold, dry, nearly airless desert we see today. The moon, smaller still, cooled long ago into a dead ball of rock, its interior quiet, its surface unchanging for billions of years. These worlds show us what it looks like when the inner fire goes out. The geology stops. The shield falls. The world grows still. The Earth is different, larger, hotter inside, still vigorously alive at its heart, still churning, still generating its field, still building mountains and shifting continents and breathing out volcanoes. Our living interior is not a given. It is a piece of extraordinary good fortune, a consequence of our size and our composition and our age. And it is bound up with the fact that life has been able to endure on the surface for billions of years. A dead interior may well mean a dead surface in the long run. We are alive up here in part because the planet is still alive down there. The warmth beneath us is not just heat. It is, in a real sense, part of what keeps the whole living world possible. but that is unimaginably distant. A future so far away that the sun itself will likely have transformed and ended life on the surface long before the core grows cold. For all of human history, and for all the history that any of us can meaningfully imagine, the heart of the earth burns on, the mantle churns, the iron sea spins, the dynamo holds, the shield stays up, the hidden heart keeps beating, slow and steady and sure, and it is all connected. That's the thing to hold on to as we begin to rise. The deep and the high, the buried and the living are not separate worlds. The slow churning of the mantle moves the continents, opens and closes oceans, raises the mountains, builds the very ground that life lives on. The freezing of the inner core helps power the magnetic field that keeps our air from being stripped away. The volcanoes that rise from the deep have, across the ages, breathed out the gases that helped form the atmosphere and the seas. The heat from below drives the slow recycling of rock that, over hundreds of millions of years, helps regulate the planet's climate, keeping it, more or less, in the narrow band where life can endure. The living surface we know, the forests, the oceans, the soil full of worms, the thin warm skin where everything we love resides, sits upon and depends upon the burning hidden engine far below. We are surface creatures, sunlit and brief, but we are kept alive in part by the deep dark fire we will never see. You have come a long way down tonight, all the way to the center and back to the edge of rising. And the strange, lovely truth is that this whole vast hidden world, the soil in the caves, the deep biosphere and the unopened door, the sea of stone, and the two ancient continents, the ocean of iron and the frozen heart and the weightless centers, all of it is beneath you right now, exactly as it has been described, holding you up, keeping you safe while you rest. Closing. So here we are, having traveled as far down as anything can go, all the way to the still point at the center of the world, and now gently beginning to rise. We rise back through the solid iron heart, back out across the great churning ocean of molten metal, up past the two old continents resting in the dark, up through the long, slow sea of stone, through the door we have never opened, through the deep rock with its hidden patient life, up through the caves and the dark rivers and the ancient water, through the bedrock and the worms and the thin living soil, until we arrive once more just beneath you, at the surface, at the skin of the world, at the quiet place where you are resting now. And isn't it a strange comfort, in the end, that all of that, all that heat and pressure and motion, all that depth, all that burning hidden machinery is happening right now beneath you, not as a threat, as a foundation, the most stable thing there is, the ground beneath your feet, which has held every step you have ever taken, held up by the deep, slow fire of a world that has been burning for 4.5 billion years and will burn for billions more. You don't have to do anything about any of it. You don't have to understand it, or remember it, or carry it. It will keep turning whether you think of it or not. The mantle will churn while you sleep. The iron sea will spin. The dynamo will hold its shield over the night sky. The inner core will freeze by a fraction of a hair, a little larger before morning. All of it, faithfully, without you. The deep world asks nothing of you. It only holds you up. And maybe there's something to learn from the deep as you drift off. The center of the earth is the stillest place there is, surrounded by the most motion. It is weightless, held by everything. It is the bottom of every descent, the place where down finally stops, where there is nowhere further to fall. Sleep is a little like that, too. A letting go, a sinking down through the layers, a release of the weight you've carried all day, until you reach a still place at the bottom where, for a while, there is nothing left to hold and nowhere further to go. So let yourself sink now, the way warm rock sinks, the way water finds its way down through stone, slowly, with no effort, in no hurry at all. You don't have to climb back up tonight. You can stay down in the warm dark for as long as you like. The surface will still be there in the morning. The sun will rise, the ground will hold. Wherever you are, whatever the ground is like beneath you, stone or sand or soil, north or south, the deep cold earth or the warm red clay, you are resting on the same vast, patient, burning heart that holds up all of us, held by the center, held by the deep, held by a world that has kept its quiet promise to hold things up for longer than there have been eyes to notice. Rest now, not because the journey is over, but because you've gone far enough down for one night. The heart of the world will keep beating. The deep fire will keep its watch, and you can let go all the way down into the warm and the dark and the still. Sleep well, traveler to the center of the earth.